Thank you everyone for joining. We are super excited to bring you our second season of the In the Field webinars. This is brought to you by The Growing Point, which is our extension platform from Alberta Wheat and Alberta Barley, where we bring agronomic information to producers and agronomists. My name is Jeremy Boychyn. I am the Agronomy Research Extension Specialist with Alberta Wheat and Barley, and I'm going to facilitate this session today. I want to introduce Holly Gelech, who works at SGS Canada in Sherwood Park, and she will be presenting today on Fusarium tests and what they mean and how they work. But before we get too far into that, I just want to give a few words on the background and housekeeping of In the Field webinars. So for those of you who are familiar with Alberta Wheat and Alberta Barley, we have a very much hands-on approach to agronomy and extension. To assist with this, we developed the Growing Point, which is our science-based agronomic platform where we share agronomic information to producers and agronomists. Considering the gathering limitations that occurred last year, we decided to bring agronomic information via kind of an online video platform, if you want to call it a webinar. And we developed the In the Field webinars to fill that agronomic gap for those who are looking for timely agronomic information that's going to help them with decision making in the field, or with seeding or whatever it happens to be. So the In the Field webinars are here to help producers stay connected with agronomic knowledge from industry experts like Holly. So for housekeeping, we're going to have a 20 to 30 minute presentation from Holly, and then we'll have time for Q&A after that. There's three ways that you can ask questions. You can use the Q&A button. You can raise your hand and I can give you the opportunity to ask a question. Or you can use the chat function, and I'll be keeping an eye out in the chat to see whether I can capture any questions. But if you really want to have a question answered, I suggest using the Q&A button, because I'll be keeping a close eye on that to make sure that those questions are getting answered. All of those options are along the bottom of your screen if you're on the computer. If you're on the phone or on a tablet, you may have to swipe back and forth to find those options. But those are the three options, and you can find one to hopefully get a hold of us. And feel free to capture any of this and share it on social media, on Twitter. You can hashtag The Growing Point. We enjoy seeing your engagement on there. You can also tag Alberta Wheat and Alberta Barley, or even if you want, you can tag me. I won't be too upset about it. But those are kind of all the housekeeping things. Other than that, we're excited to present the first In the Field webinar with Holly Gelech. So take it away, Holly.
Most excellent. Thank you, Jeremy. How's my volume? Okay.
Sounds great.
Excellent. Okay, so In the Field, that's why I put up a beautiful picture here of beans. I know this doesn't look anything like typically what we see in Alberta, but I just love the picture. So welcome. So my name is Holly Gelech. I've been in the seed testing industry now for over a dozen years. Prior to that, I worked for a company called Proven Seed, which is now owned by Nutrien in pedigree seed multiplication. So I've been in the Fusarium testing world for many years, right from when it first became a problem in Canada. And then moved into Alberta and the different pest management that we brought forward back in, I believe it was 2003. So I grew up just outside of Edmonton. I'm not from a farm, but the rest of my family was all from a farm. My father was involved with Alberta agriculture and value-added initiatives in our province. He worked with setting up some of the companies that have been around for years in the process of granting, such as Spitz sunflowers and the Coyote pancake mix. He worked very closely in bringing value to farmers and producers. So I'm a U of A ag graduate from plant science, and right now what I'm working on in my local community is a community garden I helped establish with my neighbor 3 years ago. We're growing. We have 15 beds now, and very, very much interest from our local community. I reside right in Sherwood Park, so it's really great talking about agriculture to my neighbors who really don't know much about it. I also work with Seeds Canada as a board member, as well as a chair of the Diversity and Inclusion Group. So So what day is it today? It's Thursday, right? Throwback Thursday. So I wanted to show you a picture that is a throwback one. So up here in the top right-hand corner, you can see it here. Photo credit is from Canadian Grain Commission. This photo has been around for years and years and years. And these are kernels that have been proven to have a Fusarium, FDK. So on the far right-hand side, very, very little symptoms. You probably would see it on there if you flipped over the grain and looked at the crease, the slight whitening of the crease, and then moving it all the way to this kernel on the far left-hand side is totally annihilated by Fusarium. So what's at stake here, guys? This is metric tons per acre that you're producing. It's your grade. So keep in mind, grain elevators will grade on site for the presence of Fusarium damaged kernels, so FDK percent. So if you hit a certain benchmark, you will get downgraded, which obviously speaks to profitability. Then there's end use quality. So these are the bakers out there, and what's happening with them? What is the quality of the bread? Is it rising? Is it not? But most importantly, as we talk about outside Western Canada is our leadership position in the grain industry. Canada is very, very important, and the export business is very important to our country as a whole. From what I see in the lab is more just really a small micro part of it, and that's on germination testing. I wanted to show you this picture right to begin with. A few years ago, Fusarium gram had very high infection rates in Saskatchewan. They had multiple years of hot but very, very wet, especially out of kind of the Yorkton area. And we were having results of Fusarium graminarium testing in that 20-30% infection level. So I wanted to demonstrate and show to producers what we see in the lab, bring you to the lab. On this picture here, we planted, this is a germination blotter, 50 seeds, and we planted it as per usual, put it in our chambers as per usual, and within 2 days in our 20°C chambers, you can see that the Fusarium mycelium was popping out of the seeds and starting to grow. And within 3 days, what we already saw is kernels that were destructed by the pathogen, and the pathogen kept moving across the blotter. So we see this all the time in our lab with heavily infected kernels. So I wanted to bring in perspective what we see in the lab. So testing timeline, when should you test for Fusarium? So right now we're winding down our seed testing season. So of course, right January through till April, it is typically, post cleaning or just prior to cleaning, testing for Fusarium gram. Also carryover testing in some cases, bins are carried forward for seed quality and they are retested for F gram. Something you may not know is, even though we are a seed lab, we work with other materials. We work with soil. We also work with tissue as related to Fusarium. So in the month of July, you'll know your wheat crop it's tailoring out, it's heading out. And to understand, I'm not going much into the disease cycle itself, but how Fusarium gets into the head of your plant is not directly from the seed that you planted. So if you plant a Fusarium infected seed, what it does is it sprouts within and starts moving up the plant, and it gets filtered in the nodes. It doesn't end up getting all the way to the top to the grain itself. Those grain heads that are infected are from spores that are windborne that come from residue that from the prior crop year. So that's really important to understand. So in July, we do node research, and I'll get into that a little bit later. We also do in the growing conditions, in season grain diagnostics. So this is where agronomists, they're tromping along in the field and they see heads that have some typical symptoms of Fusarium. That would be the white heads. Now and then we do get some questions on, hey, I see some orange fungus that appears to be growing, on the outside of the wheat head. So we do a fair bit of testing as well in the growing season. I'll touch base later. And then once harvest occurs, that's when the pre-cleaning testing starts. So what do we test? We test the susceptible crops. Durum by far is the most susceptible to this pathogen, followed by wheat, barley, and oats. So oats, we rarely used to find it in the lab when I think back 5-10 years, but it's starting to show up more and more. And I think it's because the disease is becoming more endemic across the province of Alberta. So that is still a flag to consider, to still test your oats for the presence of the pathogen. So when we're doing the cereal heads, so this is during the growing season, typically in August and first part of September, and you're concerned, you've never seen it in your fields before, and you think it might be Fusarium. What we do recommend is targeted sampling. So take those specific heads you're concerned about, thresh out those symptomatic heads, and send the sample to our lab. We have also received the heads themselves, so you can target that as well. But what we're going to want to do is we're going to want to test, we're going to plate 200 of those seeds. So please target between 250 and 300 seeds. Then in the fall, once the crop has been harvested, we test seed, of course. So what we recommend is to submit 250 grams to the laboratory, and that will cover your other seed quality testing, not just your Fusarium. It will cover your germination testing, your vigor testing, and any other diagnostics that you want to run on it. When you're talking nodes, we're talking practicality here, is that this is primary for research organizations, but if you do have an inquisitive mind and you want to see very early, if there is some Fusarium that's starting to grow in your crop, in the nodes in particular, you may also submit nodes. We recommend 100 nodes. It is, I don't say 200 because it is a pain to sample. You are scissor cutting each individual node, a couple centimeters on each side of the node, and then submitting them to the lab. Very, very important to get them to the lab quickly. It's green, it's fresh material. It can't sit in Canada Post for a week and get moldy. It has to make our lab within 24, 48 hours, which would mean courier shipment or drop off at one of our 2 labs. We have 2 labs. One is in the Peace Country in Grand Prairie, right in the town of Grand Prairie, and then the lab that I work out of, which is Sherwood Park, just outside of Edmonton. Okay, now getting into the 2 tests. So Fusarium testing, there's a lot of questions around it because there is 2 different test methods out there. And I'm going to run through each one and give you, a guideline to follow at the end in regards to what you've seen in your area. So when we do the DNA test, we take roughly 50 grams. So you can calculate that in your head, how many kernels that may be, 1,000, maybe even more, depending on your TKW. You can figure that out on your own. So it is a large sample set that we are working on. We take the sample, weigh it out, and then we grind it into a flour. And then that flour mixture is put into microtubes. And you can see Anu here, she's one of our analysts. She's working on preparing the DNA extract. Once she has done that, the pipettes then go into our robot. This is a machine that dispenses micromilliliters of reagents in order to set up the PCR, which is the polymer chain reaction. And once that step is completed, it is submitted into our DNA machine, which is a BioRad real-time PCR equipment. Now from there, it is run. And you may hear a number of different terms, PCR and amplification, all these fancy terms. But really what we're doing in there is we are replicating the DNA in the sample to it's at a point where we can identify it or not identify it. It goes through a number of cycles over and over and over again. Over a period of a couple hours. And then at one point, we know at a specific cycle, if there is Fusarium, it is amplified. We are notified through our computer that it is there. If at that specific cycle it is not there, there's no amplification of DNA, then we know it's not detected. So what result comes out to you when we do a DNA test? The result is either detected. So it is a yes/no answer. Or not detected. So we did not find it in the sample. What does this really mean? And for a producer, it's very important to understand is that if you receive a detected result, it proves that Fusarium gram was present in that sample, 100%. We know that it is there, whether it was an internal or an external infection, because keep in mind, we are grinding the grain, the fresh grain that is submitted to our lab. So one thing that is a bit of a limitation is it will detect the spores, but it doesn't tell us whether those spores are alive or growing or viable. So that would be one of the limitations of a DNA test. If we have a detection, we automatically move it to a plate test, because what we want to do in the plate test is to, 1, quantify how much do you have, as well as evaluate whether the spores are viable or not. Now let's talk about the plated method. Now the plated method is very, very, very different. What we do in the plated method, now this is the method that was brought forward when the Fusarium management plan was launched, and this is the core test that has been used over the years. The DNA test has been around for 6 or 7 years. The plated test has been around for much longer. So what we do first is we surface sterilize this portion of the seed. And as you can see in this picture here, we have, these are T-balls, and we soak them in a light bleach solution to get rid of all the bacteria. And that's one thing that as cereal farmers, you're going to start hearing more about is bacteria. Seed labs have always worked in fungus. Fungal pathogens, whether it be storage fungus, seed-borne fungus, saprophytes, not saprophytes, but you're going to start hearing more about bacteria. And that's something that for us in the fungal testing world can be very challenging because it can impact the test results and actually stop the growth of fungal species, which is what we do. So after the light bleaching, we then move the seeds and we plate them manually under sterile conditions in a fume hood. We plate 200 seeds, 10 seeds in each plate. So there's 20 plates that are created from there. And then they go into our incubation chamber, which is a walk-in specialized chamber for fungal pathogen growth. Lights not just on the top, but go right from the floor to the ceiling. After an incubation of 5 to 7 days, we start moving on to analysis. So as you can see here, this is Anu again, one of our technicians. She's starting the process of analyzing for the presence of F-gram. So as you can see, we have all of our plates here that she's looking at. So one specific row would be one sample. So her first thing is that she is looking at the plates for the presence of pink or slightly orange fungal growth. So this is an example of a couple of the plates that we've pulled here. So it's a visual, just just looking at it. From there, then, we need to distinguish between different species of Fusarium. And the only way to do that is to actually take a portion of it and put it on a microscopic slide. And that's what Nicole is doing here, our pathology lead, is she has subcultured from here onto a plate and is looking under the microscope for these spores. These are specific Fusarium gram spores, and they are depicted as gram because they are similar shape to a canoe. So all the different Fusarium species have different spore shapes that we look under the microscope. So now that we've done that, we would report either a % infection if we find any, or not detected in the sample. Now, what the % infection is fantastic because we can quantify for you how much you have. Do you have 1%, 2%, 20%? So that is one of the benefits of the plated test. Keeping in mind our limit of detection, so that is the lowest result we will give you, is 0.5%. So that's one. That's right. One seed out of the 200 gives you 0.5%. So that's your lowest detection. Now, the odd case that we have seen over the years, and it can be very odd, but it is worthy of a discussion because it can happen, is what happens when the DNA test is detected and the plate test is not detected. Well, it can be very confusing, and I want to clarify up is that the DNA test does not prove that the fungal pathogen is alive and is growing. So that's one thing to consider. The other thing to consider is the plate test is 200 seeds, while the DNA test is much larger, right? We talked about 50 grams, convert that out from your kernel weight, it's quite a few more for seeds. So it's something to start considering and thinking about for your farm. Now, which test to choose? Well, I would challenge you to think about what's going on in your specific area. If you're a farmer in Fairview versus a farmer in Bow Island or anyone in between, your answer to these questions are going to be different. So think about, is F-gram in your area? Okay. If it is already, consider the plate test. If you routinely find Fusarium gram in your samples, again, stick with the plate test. If on the you are seeing that the growing conditions are very conducive to F-gram, so think about that. So it's July, right? So we're July, beginning of July, the anthers are starting to pop out of the grain head. That's your critical time to be understanding, the risk for Fusarium testing. So if your weather during that time period is warm, it's very humid, it's moist, that is something to be alarming for the production of Fusarium gram spores from the residue, right? That gets windborne and can land on the heads, on those anthers, right? So those are the things I would consider for the plate test. Now the DNA test is great if you're in a rush, right? So your seed cleaning plant is called you and said, okay, I need your grain to be delivered within 3 days. And you realize you haven't done your testing yet. And the plate test takes 5 to 7 business days, right? We have to grow the fungus, right? So you are out of luck. So your answer to him is either you do a DNA test, which takes 48 hours, or you're going to have to wait to the next run at the cleaning plant. The other use for a DNA test is if you really want to test a large amount of kernels. It's really an early indicator of, whether you have that disease or not. Another test that we do, and I want to cover this because it's a very popular test in Saskatchewan, and I suspect we're going to start hearing more and more, not only about F-gram, but also about the total Fusarium species. So we also do a test where we do a comprehensive plated test, same method as I talked earlier, but we will identify 5 Fusarium species that are common in Western Canada. Now, keep in mind that all these, the 5 that I've listed below, will and can have the potential to produce mycotoxins, with the exception of Fusarium avenaceum. So they are of concern. And F-gram has always been the pathogen that has caused the biggest concern for Western Canadian farmers, but the other ones are here, and they are something to consider as an additional comprehensive tool for diagnostics. So why I say Saskatchewan has used total Fusarium as well as how much F-gram is in a sample, they use that for best management practices. So the government in Saskatchewan put forward some recommendations a number of years ago that if your total Fusarium is above X%, then we recommend you seed treat or you source extra different seed lots. So this is something to become knowledgeable on, as that is something that we can also test for in the lab. And as you can see, I talked about earlier, these Fusarium colonies are either pink shades or shades of orange. So each one of these pop up, they go straight to the slides under the microscope for evaluation of spore shape and morphology. So this is hot off the press. I'm very excited to present this because this is something of a fantastic tool available for farmers in Alberta. And this was just launched here about a week and a half ago. So the contributors to this project is the Alberta Seed Processors Organization, the Canadian Agriculture Partnership for funding, 3 about Alberta seed laboratories. So that's ourselves, SGS, as well as 2020 Seed Labs, as well as Seed Check. So the 3 labs are now providing data by postal code on the testing we are doing for Fusarium graminearum. And from there, it is then passed through Dr. Harding's desk and presented in a format of a map. Now, I know probably with this presentation, you probably can't zone in specifically on your county, but in a general way, this is a 3-year project, very exciting to start watching the trends of detection of this pathogen. So this is data that from the fall, so September 1 until December 1st. So that was kind of the harvest season. In most cases, this would represent maybe 35–40% of the testing we do, because we do test all the way up to spring seeding. So what's going to be presented to the marketplace is this, I believe, on roughly kind of a quarterly basis. How the data is presented is the white in this specific areas, or there's no testing, and that makes sense, right? So you're talking the mountainous and the far east side of the northeast side of the province. Then the next one is 0 to 1%. Of this percentage of samples positive for Fusarium gram. So that specifically, it's not a test result. It's just the number of percentage of samples that were submitted from that county that test positive for the test. So whether it is done by DNA or whether it's a plate test, doesn't matter. It's all compiled into one. So as you can see here, going down the data, anything on the dark, almost the brown into the reds, we're seeing quite a high percentage of the samples that are positive for Fusarium graminearum. So this shows that, you know, in most regions we are picking up Fusarium. So I do want to direct you to the website in the next slide, where you could find this map and take a closer look for your county. So the next steps. Okay, so the big primary step here is for you to understand where the sources of these spores are. They're from the residue that do get windborne and splashed around and up into the heads. But the other consideration is seed. What you're planting in the ground now is important. Not only from that's going to produce residue with potentially F-gram in it, but it's also going to impact your germination. You know, your stand establishment. Stand establishment is so key, right? So that's the other thing to consider, is where Fusarium impacts you on your farm. So here's some great resources I wanted to leave you with. A final part of my presentation is that I encourage you to visit the integrated pest management information on managefhb.ca. A great website, take a peek of it. The Fusarium head blight risk maps. Now, I assume they're going forward this summer. These are maps on alberta.ca that take in consideration the weather, right? During the growing season. And these maps were fantastic to help, you know, tell you, is there a high risk or a low risk? So again, I don't know if this will be going forward this summer, but something to watch out for. And then the surveillance data that I gave you here on the prior slide can be found at seedprocessors.ca. So that wraps up my part of the presentation. I hope that I've been able to, you know, encourage you to think about Fusarium. Yes, it is Throwback Thursday. You know, I think for some of us, we've been working with this disease for a long time. We're still excited to communicate new developments, especially on the surveillance side, as well as, you know, encourage the conversation about what test to order, all based off of, you know, your past history as well as weather. So thank you very much, and I'll leave it open now for Jeremy to go through the questions, and I hope to be able to answer each and every one.
Thank you, Holly. That was a very informative presentation. I know I learned a few things in there. So we do have one question up here right now, and you know, I'll say this before we get too far into it. If anyone has questions that are specific about, hey, I have this result from my seed test, how should I manage that on my farm? You know, we're gonna stick to talking about the specific tests today and how they're executed and what they mean for you on farm. But when it comes to results, that's a very different topic. So I encourage anyone who has questions like that to reach out to me, or you could also reach out to Dr. Kelly Turkington at AAFC. But feel free to reach out to me if you have a question like that, and we can handle that on the side. But we do have one question here from Teo, and I imagine he's probably familiar with a lab bench, because his question is, what media do you use for the plate method? And I guess I'll kind of tack on to that, Holly. You know, does the answer that you're going to give make an impact to what that means to producers and how that relates to their soil, or what that exactly means?
So for most fungal pathogens, and we're talking cereal grains here, we use it's actually a powdered mix that we add water to, and it's a potato dextrose agar. So that just sounds funny, but it's just a bunch of sugars. That's really all it is. It's a fancy way of saying that, and that's a differential media used routinely for fungal pathogens and would be used at any seed lab across Canada for Fusarium graminearum testing. Now, there are other diseases out there, such as blackleg testing. There used to be a method that we used to use with a different type of differential media, which was actually V8 based. So V8, the tomato-based juice. But that was used for a different crop species and a totally different type of pathogens. So potato dextrose agar is the consistent one that is used by seed labs across Canada for fungal pathogens. And we use the same one for that for any pulses as well. So if we're doing any, botrytis, ascochyta, that type of testing, it's the exact same thing.
Wonderful. Thank you, Holly. I noticed that you had chatted about sending in specific heads that producers may be concerned about, but I'm curious then around the discussion of are we encouraging taking and sending in representative samples like we would for a grain sample at an elevator, or when we're sending in samples to a lab, do we want to be more specific like that? And maybe there's a direction you'd want to go either way. So could you just speak to taking representative samples versus being specific with what you're sending in?
Yeah, that's awesome. That's a great question, Jeremy. So what really happens is at our lab, we start getting calls from agronomists or producers that have some questions about the grain, the heads. They see symptoms of white kind of bleaching partially up, and typically those are farmers that maybe haven't had Fusarium before, right? And have always tested for year after year after year, last 15 years. So it's kind of new, and it's something that is great to target during the growing season, so that it answers the question that, oh, you know what, that wasn't F. gram, that was actually Fusarium culmorum. Okay, well now I know. It gives you that information. But keeping in mind that when we're getting your grain sample in the fall, it's truly representative, right? It's not targeted. And that's what you should do, because that's what you're putting in the ground, right? You're not putting specific heads in the ground the following year. So a representative sample is very important to gather for the winter testing that we do. I would recommend highly, and I know the fall is such a crazy time, especially with the larger farms we have, is that if you can take the sample before it goes into bin, that's perfect. Absolutely perfect. Who wants to go out when it's minus 30 in the middle of December trying to get a sample out of these large bins? It's not going to happen. So let's get the samples gathered in the fall. Put them in a sealed container. Have that sealed. If you don't send the samples right away, well, then have that container in the similar conditions to what the bin is in. So don't drag it into your office that you have set at 22.5, and this grain sits there, and maybe it's even higher moisture than maybe it should be, and it starts even growing some different types of fungus in it. So we recommend representative sampling and storing it in a cold shed, right? There's got to be a cold shed on your farm. Throw it in there if that's where you're going to put your representative sample.
Wonderful. Thank you, Holly. So we have another question here from Harry Brook. And if any of these questions are kind of outside of your realm of what you're comfortable with asking, I realize some of these are probably going to push more into the plant pathology questions. Feel free to let me know. Does FG infected seed ever produce viable seed, assuming FG free because of a node block? Not sure.
That's a good one. Good job, Harry. So again, I'm not a plant pathologist, but my understanding is a good portion of it gets locked up in the nodes. And that majority of the full out head infections that we get is from the residue that is breaking down during the growing season. The spores are released and land, on the anthers, on the head during that critical time period, usually at the beginning of July. So I can't speak to, does some slip up and go up? I can't speak to that.
Wonderful. So we don't have too much more time for other questions. I know there was a couple of questions that came up about Fusarium management practices, and Brian Kennedy actually asked another plant pathology question. When it comes to management practices, if anyone has any questions, I encourage you to go to that managefhb.ca website. All of the management practices that are encouraged by the Fusarium Action Committee are on that website, and that's updated as we go. Tiffany, I know you asked this question, so you can feel free to reach out to me specifically, and we can chat about some of that stuff. but I was curious, when you were talking about the DNA test and the viability of spores and whether they're actually viable to kind of grow and then impact the crop. Do we know maybe why a spore would come in as viable versus non-viable? And again, I know that's kind of fringing on the plant pathology side, but curious, because I mean, if we're getting those results, maybe we can make inferences to what's going on in the field.
Absolutely. So I would, believe that if you have a DNA detect in the fall, that, they're likely going to be viable, but whether they're going to be viable one time the planting season occurs, I would approach that would need to be covered from a research side on when the half-life is. Now, we know from our lab, what we do is that we have done little trials in our storage. So our storage is on standard room temperature. And over a number of months, we can see the F-gram quantification percent fall significantly over the course of sitting in the plastic bags that they were submitted in, seeds submitted in that, from the fall until the winter months. And that's at room temperature, right? So, that's why we also do encourage, that holding that sample, not in your office, holding it in a cold shed. Let's keep it at the temperature similar to the grain. But it'd be interesting to find out a little bit more, and maybe that would be your next growing point, is to bring on one of the experts such as Kelly Turkington, talk about half-life, right, and how quickly the spores do degrade in our cold climate, and what, if any, work has been done on carryover seed too. What is the impact of carrying it through those warm months, in June, July, August, and September? Does that pretty much wipe out the spores, or is there still going to be some that are viable?
Perfect. Thank you, Holly. And on that note of Kelly Turkington, we did do an in the field webinar with him last year talking about management of Fusarium head blight. And anyone who's interested, it is an hour-long discussion and conversation about management of Fusarium head blight. But Kelly has a lot of valuable information when it comes from managing FHB on farm and Fusarium graminearum. So certainly worth the time, and you can find that on our YouTube channel. Head over there and search Kelly Turkington Fusarium head blight management, and you'll be able to find that. So Kelly, Holly, that is all the time we have for today. Is there any way someone can contact you or SGS Canada if they have further questions about that? Could you share that up there if anyone wants to reach out to you? Perfect. So again, thank you so much, Holly. Thank you everyone for joining today. Please remember that as much as we brought SGS Canada on for this presentation, and we greatly appreciate them bringing us this content, there are other labs in Alberta that do Fusarium graminearum testing, and that includes 2020 Seed Labs and Seed Check Technologies as well. So feel free to work with the seed lab that works best with you and your farm. And also remember that this is a recorded webinar. We will be posting it on our YouTube channel so you can watch it after the fact. So thank you everyone for joining. Thanks for watching In the Field webinar, brought to you by The Growing Point, which is an Alberta wheat and Alberta barley agronomic extension. And keep an eye out on our Twitter. We will be having more of these In the Field webinars back May 19th at 11 a.m. And every Wednesday following that. We have a great lineup coming this year. So keep an eye out for that. And yeah, we'll continue to bring some great agronomic knowledge to Alberta producers. Thanks again, Holly.
Thank you very much.